So today we're going to be doing 3.2b, which is derivative, tangent lines, and normal lines. So if you recall from yesterday, 3.1a, we talked about a tangent line and how it represents instantaneous rate of change, the derivative at a point. We can actually find the actual equation of these tangent lines. So they're linear equations. We can find the equation of them by using point slope formula in addition to the slope itself. So here's the two formulas you absolutely need to find the slope of the tangent line. You can just use the derivative and then the point slope formula. Now there is a shortcut formula I'm going to show you in the second half of the notes, but I want to mention these two formulas right here. These will always work to find what we need. The shortcut has some limitations, so I want to show you the long way and then I will show you the shorter way. Alright, so step one. It says find the equation of the tangent line to the curve at the point 1, negative 3. So step one is we need to find the derivative of that line, or of the curve by using the formula. So the formula is limit as h approaches 0. And then in the formula, we're going to go ahead and plug in. Make sure you guys are all getting this down.
I'm getting it down.
Good job. Thank you. So step one is you're going to take your x's, yes, and you're going to replace the x's with x plus h. So our first thing we're going to write is the function, but instead of x, you're going to write x plus h. Then for the second part, you're going to do minus, and you're just going to subtract away whatever that function is. So the function as is, all over h. So that's the standard derivative formula. Now we just need to simplify everything. So I know that for this I need to factor it out, or FOIL it out rather. So I'm going to do x plus h times x plus h. You're going to see this one come up a lot, so like I said, sometimes it's just helpful to memorize what that is. X squared plus hx plus hx plus h squared. These are like terms, so these become x squared plus 2hx plus h squared. Now I can replace, and I'm not going to write the limit just to save room, but it's still there. 2 parentheses x squared plus 2hx plus h squared. And then here I'm going to distribute the negative 5. Oops, that was a 5x, or 5h, not a regular 5. Sorry about that. And then distribute again here. Minus 2x squared plus 5x. And then this is all over h. Now, before we do the multiplication, you're going to notice that some of these cancel out. So do you see how these are already going to cancel right here? So we can cancel those out, and then we can distribute again. So this is just a bunch of algebra, really. So we distribute again, and then we have that minus 5h minus the 2x squared all over h. And then we're going to check again and see if anything cancels. As you can see, the 2x squareds cancel. And everything you should have left in the numerator should have an h in it. So you should be able to factor out an h, right? So I take out an h and I get this all over h, which means I can do what with the h's? Cancel them. Remember, our original goal was to take the limit as we approach 0, right? So am I ready to now do direct substitution? Good. So what would my answer be if I do direct substitution here for 0 for h? What's my answer going to come out to be? Thank you. So this is where we would have left off yesterday. This is basically what you guys learned yesterday. So here's where we're adding in extra steps. So now we want to find a tangent line to this curve at this point. So here's how we do that. Step one is you're going to plug the x coordinate of that point into the derivative formula. So you're going to get negative 1. So I plug the x-coordinate of my point into my derivative formula. And this right here that you get when you do that is the slope of the line that you're going to create. Okay? Now, sometimes they're going to give you a point. Sometimes they're only going to give you just the x-coordinate of the point. If they give you only the x-coordinate, you have to plug it back into the function to get the y. But see how they gave us the whole point now. So now we can use point-slope formula, which is y minus y1. Well, I just did that to show you guys what it looks like. I won't give you that on a test or quiz.
And if you're gonna ask them to graph.
I wouldn't ask you to graph it, typically. I could, but like not, that's not, the goal was just to give you a visual of what this actually looks like. So now we're gonna plug these in for the point, and this is gonna go in for the slope. Okay? So point slope formula, y minus y1, which is 1, times the slope, times x minus x1, which is negative 3. So does everybody see where I got each of those three numbers from?
Yes.
Okay. Now you're just going to use algebra to simplify this. So it's just going to become y minus 1 equals negative 1. And remember, this is technically a positive 3 times a negative becomes a negative 3. I add 1 to both sides. And that gives me y equals negative x minus 2. So that's the tangent line. So does anybody have any questions about that? So if you always think about the fact that when you take the derivative, you're calculating slope, you can always remember it acts the same way as any other time that you would create a line with a slope. Just keep in mind that when you calculate the slope from the derivative, it's the slope at any given point. We have to plug that x in to find it at that exact point because it's instantaneous rate of change. So before we proceed with any more calculations, I just want you to see a glimpse of the other formulas and symbols that we use to denote the derivative. So if you see any of these, they also mean derivative. So you're going to see this one most commonly right now, but just be aware these all mean that same thing. D stands for derivative. Okay, so we're going to practice more with these other formulas, but I just want to make sure that, you know, if you're looking at any item, if it has any of these, it's the same thing. Alright, so we calculated the tangent line. Now we're going to talk about how we calculate the normal line. So the normal line is a line that's always perpendicular to the tangent line at the point of tangency. So perpendicular, you remember perpendicular from algebra geometry. Does anyone remember how two lines, the slope of two lines compare if they're perpendicular?
They have the same slope and
Not the same slope, that would be parallel.
oh.
Isn't it just inverse?
Not inverse.
Like opposites?
Opposite, not inverse, but starts with an R.
Reciprocals?
Yes, good. So they're opposite reciprocals. So in order to find the slope of a normal line, you would just take the slope of the tangent line and find its opposite reciprocal. So in case you forgot what that means, I'll just refresh your memory. So if you have the slope of the tangent line, and it's not a fraction, you can make it a fraction by putting it over 1. To take the opposite reciprocal, you change the sign, and you flip the fraction. Change the sign and flip the fraction. So what would the second one be?
2/3.
2/3. So if it's negative, it becomes positive, positive becomes negative, and you flip the fraction. Okay. So this right here is a shortcut formula to finding tangent and normal lines, okay? This formula only works when you're given x equals a. If they don't give you an x equals a, you cannot use this formula. It's only a shortcut formula. If you don't have it, you're going to do it the long way, okay? So, yeah, this is what that says here, but I just want to make sure you're aware of what that really means. So let's go ahead and try it out. it says find the slope of the tangent line using the alternate form x equals 2. So see how here they gave me the function and they gave me an x value? So that means I can use the alternate formula. So alternate formula, you take the function itself, whatever it is, minus the function if you plug in 2 for x. Not always 2, whatever x is. Like, whatever they tell you to plug in for x. Not always 2, obviously. And then it's just x minus whatever your x value is, which is 2. So now you're just going to go ahead and simplify this. So I'm going to have to find a common denominator. So I got to multiply top and bottom of this by. Good. And top and bottom of this one by. Good. So this is going to simplify to become one big fraction. 2 minus x over 2x, right? All over x minus 2, but instead of dividing by x minus 2, can't we multiply by its reciprocal like this? Isn't that the same thing as division? Now, we can try to cross cancel, however, we have a little bit of a problem. These are not identical, right? And we know that subtraction is not commutative, but what's the trick that we can use?
You can times the top one by
Negative 1, yeah.
yeah.
Yeah, so technically you could flip these and factor out a negative 1 if you want to do it the long way. But if you want to cancel two things out that are flipped, you can cancel them out, but you have to replace it with a negative 1. So the final part here becomes negative 1 over 2x. So this would be a portion of what we need, but we need to find an actual slope. So what are we going to plug in for x here to find the slope? Good, so we end up with negative 1 over 4 as my slope, and that's because I replaced x with 2. So now that I have my slope, I can use that to find the tangent and the normal line in the next steps. However, we have one little problem before we do that. We know that in order to do that, we have to use, you don't have to write this, point slope form, right? And in point slope form, I need to have a point and a slope. I have a slope and I have an x, but what am I missing? So how can I get a corresponding y value to a function if I only have its x? Plugging it into, yeah, the original function, right? So to find the y coordinate, I find it by taking whatever that x value is and just plugging it into the function. So that means I have a point at 2 comma 1/2. So now I have a point and a slope. Does everyone understand how I got that? Okay. So now on to the next page here. We're going to use that information that we just came up with to find the tangent line.
Can you go back to the slope?
Yeah. So in order to find the tangent line, we're just going to use point slope with the slope. Okay. So the slope I found and the point that we found. So that's just going to be y minus 1/2 equals m times x minus 2. Distribute. And this becomes plus 1/2. And then I add 1/2 to both sides. You get y equals negative 1/4 x plus 1 as my tangent line. So to find the normal line, you're going to use the same point, of course, but there's one thing that we're going to change, and it's going to be the slope. So if the slope of my tangent line is negative 1/4, what would be the slope of my normal line?
4?
Good. Yeah. Do you guys understand how I got 4 for the normal? So that's like a vocabulary type question I could ask you on the exam. Okay. So now you're just going to do the point slope formula again. I see my mistake. I meant to put 1/2 there. So then I just distribute.
Shouldn't it be 4 over 2, not negative 1/4?
Oh yeah, the whole thing that we just talked about, yeah. We're just calculating the tangent line again, just for fun. That gives you y equals 4x minus 7.5. So for the test, the exam, and the quiz, you'll need to be able to find a tangent and a normal line.
Is this where we're stopping before the quiz and the test?
This is where we're stopping what?
Before the quiz and the test?
It's done
Yes, we are. We are gonna